me again, and this is Chapter 11 of Grade 5, Geometry. Yes, I'm pretty sure we went through this maybe sometime before, but our first section is, well, perimeter. What is perimeter? Perimeter is the total length of all the sides. Think of it like, well, a fence. And you're trying to fence a certain area. And then you're trying to find out how much fence you need. Yeah, perimeter is like that. So to find the perimeter of a figure, add all the side lengths. Simple, right? Now let's do a practice. What's the perimeter of this side? Well, there's 6 centimeters as one side, 7 as another side. Oh, okay, that doesn't look that much, okay. That doesn't look longer, but I guess diagrams aren't usually drawn to scale. They aren't usually drawn to scale, which means that they aren't usually drawn actually accurately. It's just there for you to have a very vague, not very good image of it. 4 centimeters, 2 centimeters, 5 centimeters, 8 centimeters. Now, what's 6 plus 7 plus 2 plus 4 plus 5 plus 8? Well, 32. So the perimeter is 32 centimeters because it's the sum of all of the side lengths, which is 32 centimeters. So let's do some practice. Find the perimeter of each figure. What's it for this one? Well, we can see that this is a rectangle, or at least it's supposed to be a rectangle. So we know that the opposite sides of a rectangle are, well, equal in length. Or, well, width, if it's a width. So we have 2 feet plus 2 feet. You don't actually really need to write the feet unless your teacher really wants you to. But you need to write the feet in the final answer. 6 feet and another 6 feet. And then that is equal to, well, 16 feet. This is where you really need to actually write the feet. Now you may be wondering, a perimeter for a rectangle is just 2 times the length plus the width. Yeah, that's the formal way we write it. But most of the time in grade 5, they don't teach a distributive property, which involves, well, brackets. But by the time you're in grade 5, you should know PEDMAS or BEDMAS or please excuse my dear Aunt Sally. Ah, yes. Okay. These two are interchangeable and these two are interchangeable, but it's basically parentheses or brackets first. So brackets first, you calculate this, and then it's exponents, which we don't teach you yet, second, and then it's the multiplication and division together, and then it's addition and subtraction together. Yeah, that's the order of operations. But moving on, since we haven't really gotten there yet, 60 millimeters and 20 millimeters. Okay, this is also a rectangle, which also means it's just, well, 2 times length plus width. Or you could just do, well, length plus length plus width plus width. Yeah. Either way, you get, well, for this one, you get 20 plus 60 equals to 80. 80 times 2 equals to 160, so 160 millimeters. Oh, wait, that's meters. Millimeters. And then this one, it would be 60 plus 60 equals to 120. 120 plus 20 equals to 140. Plus another 20 equals to 160. So that would also be equal to 160 millimeters. Either way, it's the same. Oh yes, for brackets, you could write the multiplication sign, or you, well, could just not write it like I did, or didn't do rather, up there. Yeah, it's a bracket thing. It's also an algebra thing, which we don't really talk about in grade 5. Moving on, extra information is always good. Oh, this one's a triangle. So you just plus the 3 sides together, or add. 4 millimeters, 4 millimeters, 7 millimeters. So we have 4 plus 7 plus 7. And what's this? 18. So 18 millimeters is a perimeter. Oh yes, P stands for perimeter, so it's best if you write P equals to 18 millimeters. And usually, we would have a name for a shape that isn't like Sally or Bob or triangle or Steven. It's usually, for example, if this was A, and this was B, and this was C, then this would be triangle ABC, and this would be called, well, not called, it would be written P triangle, yes, that's a triangle sign, ABC equals to 18 millimeters. But right now we haven't really named the shapes yet. So happy, lucky, cotton candy, fun times. We just need to write P. Question number 4. Oh, it's another triangle. Yeah, what's 5 plus 3 plus 4? 12. So P equals to 12 centimeters. Anyhow, you got to be careful about the units because, fun fact, if you wrote 12 millimeters, or rather 12, well, meters, or anything that isn't centimeters, chances are your answer is going to be very, very wrong. Imagine telling somebody that you need, let's see, you want to make a string fence. Okay, that doesn't make very much sense. But, oh, okay. You want to make a series of tripwires that make a square. And it turns out that you need 16 meters of tripwire. Tripwire is wire that, well, you trip on. And then you tell the person you need 16 kilometers of tripwire, or 16 centimeters of tripwire. Well, you're gonna get very different amounts from what you initially wanted. Now we will move on to question number 5. Oh, this is a very weird pentagon. Okay then. 5 meters, 2 meters, 3 meters, 3 meters, 2 meters. What's 2 plus 3? 5. There's 2 plus 3s, so what's 2 times 2 plus 3, or 2 times 5? Because the 2 plus 3 is in brackets. 10. What's 10 plus 5? 15. If you want me to write that out, it would be 2 plus 3 times 2 plus 5. Okay, so now we follow PEDMAS, or BEDMAS, or please excuse my dear Aunt Sally, Sarah, whatever you want the S to be, Stephanie. Anyhow, so brackets, parentheses first, that's 5, and then it's multiplication, well, it's exponents, but there are no exponents, so we skip that. So then it's multiplication or division, and there's, well, multiplication right here, so that'd be 5 times 2 equals to 10, And then it's addition or subtraction, and then that's addition right here. So 10 plus 5 equals to, well, 15 meters. P equals to 15 meters. Yay! Now we have questions 6, 7, and 8. Okay. That's an equilateral triangle. Remember what equilateral triangles were? We learned this in, I think it was grade 4. Remember? It's a triangle with, well, an equal length for all 3 of its sides. So when it has an equal length for all 3 of its sides, does that sound like multiplication to you? Yes, it does. So 4 plus 4 plus 4 is also 3 times 4. I'm going to write this out just in case. Which is equal to what? 12 centimeters. P equals to 12 centimeters. Oh, that's a square. That's a square for sure. Well, it's a square. Squares have 4 equal sides. Each side is 2. So that would make 2 plus 2 plus 2 plus 2 equals to 2 times 4 equals to 8. And that's inches. Inches. P equals to 8 inches. Okay. Then there's question number 8. 3 centimeters and 7 centimeters, and this is a rectangle. Even though it's slanted, it's still a rectangle. Well, it might be a parallelogram, but parallelograms, well, it's the same thing for a perimeter. That'd be 2 times 7 plus 3, or it would be 7 plus 7 plus 3 plus 3. Yeah. You can probably tell why it's 2 times 7 plus 3 because there's 2, well, 7 plus 3's. Anyhow, both of these equal to, well, 20 centimeters. So P equals to 20 centimeters. Now we're done section number 1. And we move on to area of parallelograms. Because, well, find the area of a parallelogram. The formula is base times height. The height of the parallelogram is the base to the other base. Well, the length of the base to the other base. Distance, more like it. Because length would be sides. And the side, well, it's not equal to the height, usually. Unless the parallelogram is something like a rectangle or a square, it's not. So the formula is A for area. A is always for area, and always use capital A. Just like P, always use capital P. Equals to base times height. You don't even have to write the multiplication symbol. You could just write BH. Because B stands for base, H stands for height. Now what's the base length? Well, it's 1 unit, 2 unit, 3 unit, 4 unit. So in this one, A equals to 4 times, what's the height? 1, 2, 3 unit. 3. A equals to, what's 4 times 3? Call upon that grade 3 knowledge of multiplication tables. 12. 12. And in this one you say units squared. Okay. One important thing about units Because we don't know how long each of these units are, you can't write like kilometers or anything like that. You have to write units. But the problem with units is that some teachers will allow you to write the short form, which is just U, and then just do the squared sign. This is an exponent, by the way. But some teachers, well, they won't. They insist that this isn't proper enough. So they tell you to, well, write the whole thing, which is tedious, I know. But, well, sometimes the teacher will mark you wrong for writing the short term. Well, yeah. That's about it. Teachers, I know, right? You have to ask every single one of them what they like. Find the area of each parallelogram. Area is, well, h times b, or b times h. Since 3 times 4 and 4 times 3 is equal to the same thing, the order doesn't really matter in multiplication, nor does it matter in addition, but it does matter in division and subtraction, so please don't mess up the order. Anyways, base is 1 unit, 2 unit, 3 unit. So 3 times, height is 1, 2, 3, 4, 5. 3 times 5. What is 3 times 5 equal to? 15. So A equals to 15 square units. You could write square units too, or units squared. Some teachers don't care which one you write. Other teachers do. Make sure to ask the teacher. Make sure, guys. Anyhow, moving on. Base is, this time it's 1, 2, 3, 4. 4 times. Height would be 1, 2, 2. 4 times 2. 4 times 2 is multiplication, guys. 8. Now, oh, the base is smaller this time. Warp. Yeah, the base is 2. So base times height, it would be 2 times height. And height is 1, 2, 3, 4, 5. Height is 5. So 2 times 5 is 10. Area is equal to 10 square units. Of course, we also usually name parallelograms in higher grades, such as, well, actually we name every single shape. We just letter all the vertices and put P, A, B, C, D, or P, J, K, I, F. Sometimes the letters don't have to be in order, but they usually are. Anyhow, area for this one. Oh. Okay, this time they actually give us units, which are feet. So area is base, which is 8 feet. So 8 times 7 is the height. So 8 times 7 equals to 56. 56 square feet. Or feet squared, you could say that. Now you might be wondering why you have to put the squares. It's because it's like 8 feet times 7 feet, and then 8 times 7 equals to, well, 56, and feet times feet equals to feet squared. A. Yeah, it's kind of weird. I'm not gonna lie. Now this one. 30 centimeters is a base, so area equals to base times height. Base is 30, height is 90, so 30 times 90 equals to 2,700 centimeters squared, because the units are in centimeters. Oh, 5 inch and 5 inch, okay. That's well, easy. Area equals to base times height. Base is, well, 5 inch. Height is also 5 inch. So that'll just be 5 times 5, 25 inches squared. Yay, we're done that. Now, we're on to section number 3, problem solving strategy. Again, make a model. Okay. After 2 chapters with me, this is the third. I'm sure all of you know how much I dislike this strategy because it takes way too long. You don't have the resources on a test, and even draw a picture is better, but we're still going to teach you it. Pedro, is it Pedro or Pedro, is laying out tiles for a design in his bathroom. The area is 20 inches by 16 inches. Wait, let me get something straight here. 20 inches is about this big, 6 inches is about 16 inches is about... I really hope this isn't his entire bathroom. And the tiles are 2-inch squares. How many square tiles are needed to fill the area? So step 1, understand. Well, we know that he is laying out tiles. The tiles are 2-inch squares. And the area he needs to lay out tiles for is 20 inches by 16 inches. And we know that what we need to find out is how many square tiles are needed. Yeah. So we're supposed to make a model. And our plan must be make a model, so we really don't have a choice in this. So carry out our plan. We get a piece of paper, we cut it into 20 inches by 16 inches, and gosh, well, heavens forbid that we cut out something wrong by like a 1/16 of an inch. And then we, well, cut out a bunch of 2-inch papers. And then we arrange them. Don't do this outside. The wind's gonna blow everything away. In fact, don't do this at all. Just use a calculation or draw a diagram. Because fun fact, guess what? The teacher isn't gonna give you extra paper on the test or extra paper and a pair of scissors to actually cut it out. So yeah, let's carry out our plan now. We get, well, the tiles. Oh no. Okay, and then we do it all over again and yada 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 yada. Yeah. You can tell how annoying this would be in real life. Imagine if your little brother or your older brother or your little sister, older sister, or somebody walks by or runs by and then they go whoosh and, well, the papers fly everywhere, and you have to start over again. Fun, super happy fun times. Check. Is the solution reasonable? Wait, we haven't even done that yet. So instead, I'm gonna use good old division. There's 2 ways to do this. Divide the areas or divide the sides. We're gonna divide the sides and I'm gonna show you how to divide the areas in the check bit. Divide the sides. What's 20 divided by 2? Gee, I wonder. 10. And then what's 16 divided by 2? What a mystery. 8. So there's 10 tiles on this side and 8 tiles on this side. And guess what this looks like? The multiplication thingies that we showed you before when you were learning multiplication. So 10 times 8 equals to 80. 80 tiles. We need 80 tiles. Yay! Is the solution reasonable? Yeah. Considering how small the tiles are, 2 inches is like, it's not tiny, but it's not big. And considering how comparatively big 20 inches by 16 inches is, well, it's pretty reasonable. We reread the problem to make sure all our facts are straight. Pedro is laying out tiles for a design in his bathroom. The area is 20 inches by 16 inches, which is tiny, by the way, and the tiles are 2-inch squares, which is even more tiny, by the way. How many square tiles are needed to fill the area? Well, we got all of our facts straight, that's for sure. We can calculate to check our answer. Since we already used the divide the sides thing, we can't do that anymore, so we have to divide the areas. What's the area of, well, the bit that he wants to tile? 20 times 16. Because rectangles are parallelograms too. And the base is 20. The height is 16. Base times height, 16. A equals to, what's 20 times 16? 320 inches squared. What's the area of each tile? Well, it's a square, so the base is 2, the height is also 2, and it's also a parallelogram, so 2 times 2 is equal to 4 inches squared. Now what's 320 divided by 4? 80. So 80 equals to 80, and bam, we're correct. Woo, now let's do some practice, which we're apparently supposed to make a model for each of them. But honestly, if we're gonna make a block tower for, well, the first question, Hugo is making a block tower. Each block is a 4-inch square and it's 1 inch thick. If he has 32 blocks, what is the tallest height he can make with the blocks? If we're gonna make 32 of these blocks, good luck. You're gonna take hours. So we're just gonna do a thought experiment. A. So if it's 1 inch thick, then we could technically pile all the 1 inches together, like, well, something like this. Or, well, it wouldn't look this 3D because they're all right on top of each other. But we can also do it like this. We put the square side like this, and this is a 1 inch side, and the height is 4 inches now. And then we top them like that. So technically, the longest side that we could, well, stack would be 4 inches. Now what's 35 times 4? Because you have 35 of these 4-inch blocks. 35 times 4 equals to 140. The tallest. Yeah, try not to sing opera while you're doing this. Tower he can make. Yeah, this is some horrible opera, no offense to myself. Is, what was the number that we said before? Oh yeah, 140 inches tall. Now I recommend that you write down the numbers when you're actually doing them, because you're going to forget somewhere down the line. Susan wants to organize her bookcase in her bedroom. It consists of 3 shelves, and each shelf is 36 inches long. Hang on. Okay, that's a decent sized bookshelf. If she has 25 2-inch wide books, 15 3-inch wide books, and 32 1-inch wide books, will she be able to fit them onto the 3 shelves? If not, how many of each book will it not fit? Okay then. Can I just take a sweet moment and hang on. The question maker does realize that while 3-inch wide books would be this thick. Congratulations, you're reading full-on encyclopedias. Encyclopedias aren't even that thick. Anyhow, will she be able to fit them on the 3 shelves? Well, there's 25 2-inch books, and that would be equal to, well, 50 inches. Okay, you know what? Times 2. 15 3-inch, and that's 15 times 3 equals to 45. So 3 times 15. And there's 32 1-inch. 32 times 1. Okay, this one's kind of anticlimactic. 32. So her bookshelf, each of the 3 shelves, is 36 inches long. So we can fit all the 1-inch ones, and we could add another 2 inches onto it. Well, 2 inches, actually, because 2 times 2 is 4. 4 plus 32 is 36. Now we have 32 2-inch ones left. 36 divided by 2 is 18. So we can fit 18 more of these books. And we only have, well, 1 shelf left. 23 minus 18 is 5. 5 times 2 is 10. That'd be 26 more inches left. 26 divided by 3 is not divisible, but 24 is, so that'd be 8. Because 24 divided by 3 is 8, and you can't really squish another 2-inch in there. Yep. Okay, the problem with this one is how will she be able to fit them on those 3 shelves? So, no. If not, how many of each book will she not fit? 15 minus 8 is 7, so you could say that 7 of the 3-inch books will not fit. But it could also be 6 of the 3-inch books and 1 of the 1-inch books, because we still have 2 inches left. We could take 1 of the 1-inch out, 1 of the 2-inch out, and then we could shuffle them around. So honestly, this part of the question has basically an infinite number, well, not an infinite number, but an absurd number of solutions. So we could say 3-inch books, well, there's 7 of them that won't fit, or many other possibilities. If the teacher asks you to detail all of them, well, I feel sorry for you. But chances are they only want one answer. And if they mark it wrong, and you are right, you could argue it out. Actually, no, don't argue. Arguing is not a good solution. Civilly speak it over. Debate. Debate. Patricia is making a clay game board. That's very brave of you, Patricia. I've tried making clay things. No. Each square needs to be 2 inches. If the square board will be 16 inches on each side, how many total squares will it have? Well, it's 16 inches on each side. Pretend, guys, pretend. This probably isn't actually 16 inches. It's not actually 16 inches. Now, 16 divided by 2, 8. So there would be 8 squares on each side. Yep, that's 8. That's, yeah, also 8. This is multiplication, so that 8 times 8 equals to 64. It will have 64 squares. She's gonna piece all of them together? Okay. Anyhow, Pablo Picasso, okay, no, has a sheet of stickers that is 11 inches long. Each sticker is a square. Each sticker is a square. I really hope those stickers say something on them, because that would be a boring sticker if it was just a square. With a side length of 1 inch, there are 10 stickers in each row. There is no space between the stickers. How many stickers are there on one page? So there's 10 stickers in each row. That gives you how many columns there are. So there's 10 columns, and 11 inches long, 11 divided by 1 is 11, and that's how many rows there are. Number of columns times number of rows, 11 times 10, well, 10 times 11 is 110. There are 110 stickers on one page. Oh yeah, this name. Is it Shadow or Charo? Or Caro? I'm just gonna go with Charo. Charo is making a picture frame with shells she found. Each shell is 2 inches long. Those are some very uniform shells. But okay, if she makes a rectangular frame out of 20 shells, how large can she make the frame? Oh, the entire frame is 20 shells. This is a solve backwards question. So, P equals 220. How large can she make the frame? So since it's rectangular, we know that E equals to 2 times length plus width. So what's length plus width? Well, 20 divided by 2, which is equal to 10. So she can make the frame, okay, she can make multiple frames. She can make the frame, what are the combinations that do 10? 1 by 9, 2 by 8, 3 by 7, 4 by 6, and 5 by 5. And there's also 6 by 4 and the reverse, but honestly that's the same thing. You just turned it around. So she can make all of these frames. But since this is also area, because it's how large can she make the frame, which of these gives the biggest area? Well, 1 times 9 is equal to 9, 2 times 8 equals to 16, 3 times 7 equals to 21, 4 times 6 equals to 24, and then 5 times 5 equals to, oh god, 25. She can make the frame inches, right? Okay. 25 inches squared. Okay. Tiny tidbit of information, morsel of information, crumb, whatever you want to call it. Actually, it's not that tiny. You learn about this in the later grade. Essentially, to optimize the area of a 2D shape, or well, a parallelogram, it should be a square. It should be as close to a square as possible. By optimize, I mean if you have the same perimeter, but different side lengths, the one where it's closest to a square would have the biggest area. Yeah, it's kind of weird. It just happens so. So, area of triangles. Find the area of the triangle. Use a formula. It's the same formula except not. Why is it not? Well, it's area equals to base times height is the same thing over 2. Now, why is it over 2? Because if you think about this, base times height would be the parallelogram, which would be like this. And this part is equal to this part, and this part is equal to this part. So it'd be the entire thing divided by, well, 2. So what's the base length? 1, 2, 3, 4. A equals to 4 times, what's the height? 1, 2, 3. 3 over 2. Now you could do 4 times 3 equals to 12. 12 divided by 2 equals to 6. Or you could just do 4 divided by 2 equals to 2. And there's nothing down here anymore. So it's just, well, 2 times 3. Yay, done. Area equals to 6. What's the unit? Oh yeah, units squared, or square units. Now we do some practice. Yay, practice. Area equals to base times height over 2, or divided by 2. Base in this one is 1, 2, 3, 4. 4 times. And then height is 1, 2, 3, 4, 5. 4 times 5 over 2. 4 divided by 2 equals to 2. 2 times 5 equals to 10. Area equals to 10. Now this one. Oh, that's a right triangle. Yay, which means that both the base and the height would be the 2 bits, well, side lengths. You call them legs in a later grade, but side lengths of the right triangle. A equals to B times H over 2. B is 1, 2, 3, 4. Oh, 4 times 1, 2, 3, 4. Oh, this is an isosceles right triangle. Anyhow, 2 times 4, because 4 divided by 2. 2 times 4 equals to 8. Oh yeah, you should probably put units squared. I'll just use U for this one because some teachers don't mind. So U squared, U squared. What about this one? A equals to base times height over 2. So base is 1, 2, 3, 4, 5. 5 times height is 1, 2, 3. Okay, you can't really divide anything by 2 right now. So you would end up with 15 over 2. And 15 over 2 is equal to 7.5 units squared. Area equals to 7.5 units squared. Now we move on to some real life shapes where they actually give us the units. Hurrah! A equals to BH over 2, or BH divided by 2. I'm saying BH because it's base times height, which is BH. Yay! Base is 6 times height is 9. These are in inches. Some teachers will tell you to write 9 inches and 6 inches. But honestly, some teachers just don't care. 6 divided by 2 is equal to 3. 3 times 9 is equal to 27 inches squared. And if you're wondering, yes, squared is just the thing, for example, inches, and a small 2 at the top. Oh, and this one's another right isosceles triangle, or isosceles right triangle, whatever you want to call it. And that'd be A equals to base times height over 2, and base times height is 8 times 8. 8 divided by 2 is equal to 4, and then 4 times 8 is equal to 32. And this is centimeters, right? Centimeters squared. Area equals to 32 centimeters squared. Now for this one, 5 feet by 7 feet. Okay. Area equals to 7 feet is a base, times 5 feet is a height, over 2. And we can't really divide anything by 2 over here, so we're not going to go through that step. 7 times 5 is equal to 35, and then that's divided by 2. You don't need to write a over here, just so you know. 35 divided by 2 is equal to 17.5 feet squared, or square feet. But you need to write a over here because this is a final calculation, concluding statement, and all that jazz. Now we move on to another problem-solving investigation where we choose the best strategy. Okay, this is my favorite, honestly, because you can actually not get forced to do anything that's tedious and long and takes a lot of time. Now, Alberto often goes along with his sister, Sonia, to videotape her soccer games. Such a nice brother. He records each 1.5-hour game. If she played 11 games, would Alberto be able to fit all her games on one DVD if each DVD holds 15 hours of video? Okay, I'm not sure, but from what I've seen online, some people don't even know what a DVD is now. It's that thing that you put into your television or the DVD player that stores videos. It's kind of like a USB key, except it's circular and it has this hole in the middle. Yeah, it's like what they sell movies in now, like, except they sell the actual movie, you know, at those markets. Yeah. And they used to sell empty DVDs so you could put the files onto the DVD, like how you would copy files from one folder to another right now, except when you do it on a DVD, it's called burning the DVD, because of course we just set it on fire. No, we don't. So, be sure you understand the problem. Step 1. Alberto, why did I say it that way? Often goes along with his sister, so basically we know that each game is 1.5 hours. She played 11 games, and the DVD holds 15 hours of video. And we need to know whether or not he could hold all of the games on the DVD. Well, choose a strategy. We can make a model, we can draw a diagram, and we could look for a pattern. Or we could just logic our way out of this. So we honestly can't really make a model unless you want to film 1.5 hours of random things and do it 11 times and then actually try it. No. So we could draw a number line with 11 bits. Well, yeah, 11 bits that are all 1.5 hours long and see if it fits on a 15 dashed number line. Or we could just use division. Well, multiplication in this case. What is 1.5 multiplied by 11? Now 1.5 is also 1.5. 1.5 multiplied by 11 is, well, okay, when you multiply decimals, you just do it like normal multiplication, except after you finish multiplying it, you're like, oh, there's 1 decimal place, and then you put it 1 decimal place. Mind equals blown. Yeah, so that's 16.5. 16.5 hours, or 16.5 hours. Is 16.5 bigger than 15? Yes. So unfortunately, he can't. No. Yeah. Is the solution reasonable? I mean, yeah. Reread the problem. Alberto often goes along with his sister Sonia to videotape her soccer games. He records each 1.5 hour game. If she played 11 games, would Alberto be able to fit all her games on one DVD if one DVD holds 15 hours of video? Yeah, all our facts are straight. How can we check our answer? Well, we could, just do the question again, or we could go like, 16.5 or 16 and a half divided by 11 equals to 1.5. 16 and a half is bigger than 15 hours. Well, 16 and a half hours is bigger than 15 hours. Therefore, our solution is correct. Yeah. There's many ways you can check your answer. It really depends. Just make sure that everything makes sense. Or you could just look over your entire reasoning process and see if there's any holes. Or major holes, at least. Use any strategy shown below to solve. Tell what strategy you used. Oh, God. Mitchell needs to buy enough paint to cover the fence in his yard. His fence is made out of 32 sections, and he estimates that 1 gallon of paint is enough to cover 3 sections. Okay then. I question his paint usage and I question his sections. How many gallons of paint would it take to cover his entire fence? Well, you could draw it out. Draw a diagram. Just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And then you just put them into threes. This is going to take a while. This is why I don't like the strategy. But unfortunately, we actually have to use one of them because we have to tell the teacher, oh, look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. And then there's 2 sections left over. So there's 10, and then there's 2 sections left over. But each gallon of paint covers 3 sections. We still need another gallon of paint. We still need to get another gallon of paint. Because you can't just magically have enough paint to paint the remaining 2 sections. And if you're going to buy paint in gallons, then, you can't really buy 2/3 of a gallon. Well, you could, but if the paint is sold in gallons, you're going to have a hard time. Let's just leave it there. How many gallons of paint would it take to cover his entire fence? So technically it would take 10 and 2/3. Because it says how many gallons. It doesn't really say how many cans of paint or how many cans does he need to buy. Because if it says how many gallons does he need to buy, if the paint is sold in gallons, then you would need to say 11. So 10 and 2/3 gallons would be enough. And then you write, draw a diagram. Yeah, don't sing. Try not to sing in the middle of a test. The teacher might think you're cheating or you're helping someone cheat. Callie is throwing a party and spends a total of $135. She spent $20 on cake, $40 on food, and $25 for decorations. The rest of the money was spent on music. How much did the music cost? Okay, if you're gonna make a model and ask your mom for $135 and then take off $20 or just use the Monopoly money, it's gonna take a while. You're not gonna have it at class in a test. So you shouldn't do that. If you're gonna draw a diagram, really you're gonna draw 135 dots and okay. It works, but really no. There's not really a pattern to look for, so we just use good old subtraction. 135 minus 20 for the cake, and that's equal to 115. 115 minus 40 for the food, and that's 75. 75 minus 25 for the decorations, and that's 50. And the rest was spent on music, so the rest is 50. Okay, wait, hang on. What's she doing? Buying albums? Buying a record player? Can you just YouTube playlists of music? Okay. Because $50 is not enough to hire anybody unless it's your uncle or aunt or grandmother or somebody related to you. But then again, they'd probably ask for less. Costs. Oh, maybe it's your sibling, because you know how sometimes your siblings or your cousins go to give me $10 for this if you want me to do this for you. The music costs $50. Done. And we use good old subtraction. So we move on. Meredith is saving money each month to buy a car. In January, she has $100 in her savings account. In February, she has $125. And in March, she has a total of $150. How much money do you predict Meredith will have in her savings account by the end of October? Yeah, cars cost a lot more than that. Thousands of dollars. Yeah, she's gonna be saving for a while if she keeps going at this rate. January is 100. February is 125. March is 150. So we can see that it's going up by increments of 25 plus 25. And that's a pattern. So we looked for a pattern. Look for a pattern. All right. So now we just keep going. April, May, June, July, and August, September, October. Okay, yeah, that's done. Oh, I just realized September, October, November. Oh, Jason. Sorry if your name's Jason. It's in plus 25, 175, plus 25, not 1 anymore, 200, plus 25, 225, and oh, I'm writing them too close, plus another 25, 250, plus another 25 equals to 275, plus another 25 is 300, and then it'd be 325. Yay! She will have $325 by the end of October. Yeah, when you're doing your work, do it on a separate sheet of paper so you have actually space to write your answers. So question number 4. Jordan works at a pool during the week. Monday, he worked for 30 minutes. Tuesday, oh, it's another pattern. Tuesday, so 30 minutes, the first one. Tuesday, he worked for 40 minutes. Wednesday, he worked for 50 minutes. If the pattern continues, how long will he work on Friday? So Thursday is next. That'd be 60. And then Friday, it would be 60 plus 10 equals to, 70. Because it's going up by increments of 10. He will work 70 minutes on Friday. Yay! That's done. Question number 5, last one of the section. Not the chapter yet. Roberto what's with the toes, is looking for the better deal on a bag of pens. Oh, okay. One bag has 6 pens for $3.65. Okay. Another bag is $4.98 for 8 pens. Which one should Roberto buy? Just use division. Oh yeah, we need to look for a pattern on this one. Well, that was very haphazard. Let's write division down here so we don't forget. Now, 365 or 365, $3.65 divided by 6. This is just like any old division, except for this one, you put the decimal point, well, right above the actual decimal point. So does 3 go into, well, does 6 go into 3? No. So that's just a 0. And then does 6 go into 36? Yup, 6 times, so that's just that. And 5 doesn't really work, so that's also another 0, and then it's whatever about over here. Okay, so it'd be around 60.8 cents for each pen. Now for this one, it'd be 40, well not 40, 4.98 $4.98 for 8 pens. So does 8 go into 4? No. 0. Does 8 go into 49? How many times? 6. Does 8 go into 18? Yes. 2 times. And we don't need to do any more because we know that 62 cents per pen is already more than 60.8 cents per pen. So he should buy the 6 pen pack. Okay. Could have been said as a 6-pack, but that's something different. Now, we move on to volume, and we're just doing rectangular prisms now. Volume is the amount of space a 3-dimensional figure encloses. Well, it's not exactly encloses. It's just the amount of space in general, actually, that this figure takes up. Since, if you think about it, you could have a block, well, a room, that takes up, say, this much space. But it only encloses this much space because the walls are thick. So honestly, it's the amount of space a figure takes up in general, including the amount that it encloses. To find the volume of a rectangular prism, you can use a formula. And the formula is, guess what it is, guys? V for volume, capital V. You must use capitals. Thou must use the capitals. Okay, yeah. Length times, dot in midair is also the times symbol. Width times height. Well, what's it for this one? So the length is 1, 2, 3, 4. Volume equals to 4 times. Width is 3. And height is 1, 2, 3, 4, 5. Okay. So 4 times 3 times 5 is 60. Volume is 60. Now it's not squared anymore. It's cubed. Units cubed. And if you're wondering, the short form is just a 3, written in the same position as a 2. Now let's let's do some practice. Find the volume of each prism. Well, for this one, the length is 6 units. The width is 3 units. And the height is 2 units. For this one, the length is 3 units. The width is also 3 units. And the height is also 3 units. So this is technically supposed to be a cube, but it doesn't really look like one because distortion happens. This one, length is 5 units, width is 4 units, and height is 3 units. Well, we've collected all that information. So since we know that the volume is length times width times height, what's 6 times 3 times 2? Well, that's 6 times 6, which is 36. And that's units. So units, I'll just use U, V. What about this one? 3 times 3 times 3. Which is equal to 27. It's units again, so I'll just write U again. Volume equals the length times width times height. Length is 5, width is 4, height is 3. So 5 times 4 times 3. Volume is equal to, well, what's this? 60. 60 units cubed. Okay, now we move on to the last section. But it's not over yet. Surface area of rectangular prisms. What is surface area? Surface area is the sum of the areas of all the faces. Actually, it's possible to find the surface area of a sphere. We are just not at that yet because the rectangular prism is an easier one. And we teach the easier ones first, for understanding purposes. Now, find the surface area of this rectangular prism. Now, the front face. The front face is this one. It has, well, we know that it's base times height. So base is, or length times width in this one. Length is 5, width is also 5. So 5 times 5, front face is 25. Back face, the back face is the one that we can't see at the back over there, is always the same as the front face if it's a rectangular prism. So it'll also be 25. The top face is, well, the one on the top. And it's always the same as the bottom face, too. So the top face has 5 by 6. So 5 by 6, 5 times 6 equals to 30. Oh, you should probably write units squared on all of these. So the bottom face is also 30, because the bottom face is equal to the top face. Now the right face and the left face are also equal. So the right face would be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, that's also 30. Total surface area. Okay, so there's two 25s over here, that's just 50. And there's 3 30s, well, 4 30s. So 4 times 30 equals to 120. So 120 units squared plus 50 units squared is equal to 170 units squared. Yay, done. So you might be wondering, since these two are the same, and these two are the same, and these two are the same, is there a simpler way? Well, yeah, technically there is. So you know how this is the length of the entire shape, this is the width, and this is the height, usually? It's just h times w times 2 plus W times L, well, length, times 2 plus the last one is H times L times 2. Yeah? Or you could just put it like 2 is equal to HW plus, this just means time, times, multiplied. And if you're wondering, yes, there's different types of brackets too. Like there's a small bracket, the normal ones, and then there's these box brackets, and then there's a big fancy one. Yeah. But we're not going to do this formula yet because it insists that we just do the front face, back face, bottom face, top face, right face, left face thing. So what's the front face this time? 3 times 4 equals to 12. Well, how nice, they wrote it out for us. And then the back face is the same thing, so 3 times 4 equals to 12. The top face is 3 times 5. 3 times 5 equals to 15. 3 times 5 equals to 15. Because the bottom face is the same as the top face in a rectangular prism. The right face and the left face. Right face is 4 times 5. 4 times 5. Left face is the same, 4 times 5. And that's equal to 20 for both. So now we add them up for the total surface area. Or just, technically this should just be surface area. Oh, and also, SA is a short form for surface area. This is 24. This is 30. This is 40. And we add those up, that is 94. Yay! So we move on to the last question of the chapter. Now this one. Oh, we're actually given real units here. Nice. Front face, 7 times 12. Okay, 7 times 12. That's 84. And the back face is the same thing. So that's 84 again. The top face, since this side is also 7 and this side is also 15, it'd be 7 times 15, which is the same as the bottom face. And 7 times 15 is 105. The right face is over here, so since this side is also 12 centimeters, it'd be 12 times 15. 12 times 15 equals 180. Okay, so we add all of these up. Oh, this is going to take, this is going to be annoying. And then we add those, which would be 738 centimeters squared. Okay. We're done. We're done this chapter. And guess what, guys? Chapter 11 is the last chapter that we will teach you of this course. However, this course isn't finished yet because there's still exams. The exam date will be posted on the website. But, well, use this time between now and the exams to study. And make sure that you know what you're doing. Go home. Well, you should be home right now. Study. Eat some cookies. Have a glass of water. do stuff that you normally do. But remember to study in preparation for the final exam. If you don't pass the final exam, you don't pass this course. So yeah, good luck.